Hi there. This lesson is on the applications of equations. You know what I'm talking about. The word problems. The word problems you see made fun of in the peanut gallery, for example. So before we begin, this lesson consists of a bunch of examples because that's the best way to learn this. And for every single one of those examples, I would like you to pause the video, try it on your own, try to point out key information, label the variables, make an equation, solve it, and check your work. You can then play the video and see how you did. All right, first question. Let's read it together. We've got a rock group that plans to travel for a total of 28 weeks. So total of 28 weeks that they're traveling for, making 3 major concert tours. So there's 3 major concert tours. They will be in Japan for 4 weeks more than they will be in Australia. Notice I'm already categorizing the information. Their stay in Sweden will be twice as long as their stay in Australia. So each of these statements relates each of these countries. So let's consider which ones are related in the first sentence. Japan is 4 weeks more than Australia. So if Australia was X, Japan is depending on Australia, then Japan would be 4 more than Australia. So we could try that. Now let's continue, see if Sweden can fit in here. So Sweden will be twice as long as Australia. So therefore Sweden is also depending on Australia's amount. So therefore, because everything's depending on Australia, Australia should be labeled as your variable, x. So really let x be time in Australia. And since that second sentence here tells us that Sweden will be twice as long as their stay in Australia, that would be 2x. Now you have an expression for every single place. How many weeks will they be in each country? If we know Australia, we can find the others. So let's make our equation. Total of 28 weeks, so we go x plus 4 was our Japan time, plus x was our Australia time, plus twice the Australia time, which was Sweden's time, will give us a total of 28 weeks. Now we can solve that. We got 1x, 2x, 3, and 4 x's plus 4 is equal to 28. Subtract the 4, you got 4x is equal to 24. Divide by 4, you get x equals 6. Now that's not quite our final answer. You have to always go back to the final sentence and check out what they mean. They want to know how many weeks will they be in each country. So Australia, they're going to be 6 weeks. Add 4 is 10 weeks for Japan, and double 6 will give you 12 weeks in Sweden. So you can therefore give a final answer for Japan, 10 weeks, and so on. All right, next one, we've got a sum of 3 consecutive numbers or integers, and sum implies adding together. 3 consecutive numbers means the first one's going to be x, the second one will be 1 more than that. They didn't say even or odd. If it was even or odd, it'd be 2 more than the first because even and odd skip by 2. But consecutive numbers are like 1, 2, 3, 3, 4, 5. So from the first number, you want to add 1 to get to the next, and then add 2 to get to the next one, and so on. So there's 1, 2, 3 consecutive numbers, and the sum of them is 108. So we can add up x and x plus 1 and x plus 2. And that should give you 108 total. So this was your first number, second number, and third number. Okay, let's try that. So in total, you'll have 3 equal portions and 3 extra numbers that got added on as you went up in the consecutive numbers, totaling 108. So therefore, minus 3 from both sides, you get 105 as your triple the first number. So let's divide by 3 and we get x equals 35. That's not quite the answer. Always look back to your question. Find the numbers. All of the numbers. So if the first one was 35, the next one you would add 1, which is 36, and the next one would be add 2, is 37. 35, 36, 37 are consecutive numbers and they add to 108. Number 3 is a geometry-related problem. They tell us that 2 guy wires form an isosceles triangle. Now you have to know what that means. Isosceles means the 2 sides are the same and the third one is different. So therefore the 2 bottom angles are also the same angles. And there's 2 guy wires, so we've got the 2 guy wires. Okay, first sentence has been digested. Each of the base angles, which are these bottom ones, of the triangle is 4 times the third angle. The third angle is here. So these are the base angles, and this is our third angle. What are the angles? So they want all 3 of the angles. Now, the property that we want to call up here is that the sum of any triangle, the interior angles of any triangle, the sum is 180 degrees. So that was a geometry fact we learned earlier. So let's use that to our advantage. We know the base angles, and then we know that each of the base angles is 4 times the third angle. So let's write this out. We've got base angles, and we've got third angle. So this sentence here makes the base angle depend on the third angle. Therefore, we want to call the third angle x. And then we can read it again. Base angle is 4 times the third angle. 4 times the third angle. So if the third angle was 20, the base angle would be 80. Alright, now we've got 2 base angles, so when we add them up, we've got 4x plus x gives us 180 degrees. So we've actually got 9 x's equaling 180 degrees, giving us 20 degrees each. So 20 degrees for the third angle, and the base angles were 80 degrees each. Wow, that was a fluke that I guessed that right away. I actually didn't have the answer in front of me at all. Alright, let's continue on. Number 4, we've got 3 software applications that are priced like this. So the spreadsheet's 150, database 195, word processing 210. They're sold in equal numbers, so you have to sell the same amount of each one, but 15 more word processing applications were sold than the other 2 combined. The 3 applications generated sales of $72,000. How many spreadsheets were sold? So, spreadsheet and database were the same, so let's call those X for the amounts. And here they tell us that 15 more word processing sold than the other 2 combined. So word processing, you combine the 2, so that's 2x, and 15 more would give us the number of word processing software that was sold. So now those variables that we have are the amounts of software sold. So number of software. And every time we take the number of software times the price, we get the amount of sales, and we want to find a way to represent the total number of sales to be $72,000. So the total number of sales will be taking $150 times X, and then $195 times X, and then $210 times double X and 15 more. So that should all tally up to $72,000. So if we work backwards, use our algebra skills, we can find the amounts of each software sold. So let's work this out. First, we always want to distribute our brackets. So we've got 150x plus 195x plus 210 times 2 is 420x plus 210 times 15 is 3,150 is 72,000. So let's collect our like terms. 150 plus 195 plus 420 is equal to 765. Oops. X's and 3150. So let's take away our 3150 from both sides. That gives us 765x is equal to 68,850. And divide both sides by 765, giving us 90 pieces of spreadsheet software. So spreadsheet software was 90 of those. So let's just do it here. Spreadsheet software was 90. Database software was also 90. And word processing was twice 90 and 15 more. So 2 times 90 plus 15 gives us 195. Guess that's the popular one. Alright, let's move on to another example. So here we've got a financial planner recommends a plan for a client who has this much money to invest. Wow, that's a lot of money. At the end of the presentation, the client asks how much will be invested at each rate. So he doesn't know, you're the banker, you gotta figure it out. So he's taking his 65 grand, investing it in 2 funds so that he has a better chance at making some money based on the risk. 12% per year he'll earn from the mutual fund, 6.2% he'll earn from the municipal bond. In total, he did earn $6,477.60. So remember that if you have an amount, so this is $65,000 is split into some amount here. So let's say there's X dollars put into the mutual fund. So let X equal be the dollars in mutual fund. And therefore, if you put X dollars here, then you have to take 65,000 minus X to give you the rest of the money, because he wants 65,000 in total. So that's an important aspect of many of these problems, very important. If you have a total, you take away a portion, you'll have, say, X here, and if the total was 50, you'd say 50 minus X. So that's a very, very common thing to do in these problems. Alright, so let's find the amount of money he's going to make in the first year from the mutual fund. So what we do is we want to take 12% of X, and we want 6.2% of 65,000 minus X. So taking 12% of a number means multiplying it by 0.12 and add 0.062 times 65,000 minus X. And in total, that total amount should give us the total interest that was earned from both accounts. So there's our equation. So you're basically tallying it up. All right, let's continue and solve this equation. So we multiply our distribution step here, 0.062 times 65,000 is 4,030, and then minus 0.6062x. All right, let's combine our like terms. Our x values, 0.12 minus 0.062 gives us 0.058x plus 4,030 is 6,477.60. Let's subtract the 4,030 and we get 6477.6 minus 4,030. I get 2,447.60. Now we want to divide that by 0.058. Basically need a calculator for these numbers. You get $42,200 in. You can look back to your definition in the mutual fund. So remember to define your variables. Our X was the dollars in the mutual fund. So now we can give a final answer and say mutual fund was $42,200. And we can take 65,000 minus 42,200 to get the municipal bond amount, giving us municipal bond being 22,800. And there you have it. Okay, this next one here, we've got a coffee merchant. He wants to make a 6-pound blend. Right away, this rings to me as some sort of mixture problem. So, 6-pound blend of coffee costing $5 a pound. So his final product will be a bunch of coffee that costs $5 per pound, and you'll have 6 pounds of it. The blend is made using a $6 per pound and a $3 per pound grade of coffee. How many pounds of each of these grades should be used? So we don't know the amount here and we don't know the amount here, but we know the amount totals to 6 pounds. Now, you can reason this out and just work on it just exactly as we just did with the previous problem. You could also use a table that would organize your information a little bit more. So you could take the dollars per pound, and we know that when we take our dollars per pound and multiply by the number of pounds we've got, that's going to give us the number of dollars we spend. And since we're mixing two items, we could organize it in a table. Item 1, so maybe the expensive coffee and the cheap coffee, and then the mix. So it's just a way of organizing your information. So the expensive coffee was $6 per pound, the cheap coffee was $3 per pound, the mixture was $5 per pound. Now we've got the number of pounds that we don't know, but we do know the mixture is 6. This final thing here we don't know, but we know that when you mix the expensive plus the cheap, you get the mixture. So that can create our equation later. So let's look at this concept here. the total number of pounds. So this is exactly what we did earlier. So you had 6 in total. What if you had 2 over here? How many would you have here? Well, you'd go 6 minus 2. You could rephrase that and say, let's say you had x over here. You'd take 6 minus that portion over here. So you're always going to have that when you have a total given. You can split it into 2 components that add up to 6. So same thing here, we could have put x and 6 minus x, and we know that we multiply these, multiply those, add them to get the total 6 times $5. If that doesn't quite make sense to you, you can follow the table as well. So say the expensive coffee was X pounds and the cheap coffee was then had to be 6 minus X pounds. We can't use a Y here because you haven't quite learned how to work with 2 variables with 2 equations yet. So we only know how to solve with 1 variable, so we need to rewrite everything in terms of 1 variable. Alright, so expensive coffee is 6 times X, 6x dollars, paying for the expensive coffee. 3 times 6 minus X dollars, paying for the cheap coffee, and $5 per pound times 6 pounds would be $30 total that you would be paying for the total mix. So that would come from either of these approaches. You would get the equation 6x plus 3 times 6 minus x is equal to $30 total. So you can come up with the equation right away. You can use the table, and you can use your own categorization of information if you like. All right, let's solve this here. We've got 3 times 6 and 3 times negative x is 18 minus 3x is 30. Collect like terms. 6 minus 3 is 3x plus 18 is 30. Subtract 18 from both sides. You've got 3x is equal to 12, and therefore you've got x is equal to 4. You can input that information back. They're asking you how many pounds of each should be used. So if x is 4, 6 minus x is 2. So we should have 4 pounds of $5 per pound coffee and 4 pounds of $3 per pound coffee. Let's continue on to another example. This example has to do with rate, time, distance. As soon as you see that, you can recall that we're going to be thinking of rate times time giving us distance. In this problem, we have 2 cyclists who leave the park, say the park's right here, at the same time heading in opposite directions. One is traveling at 20 kilometers per hour. The other is 5 kilometers per hour faster. Therefore, he's going at 25 kilometers per hour. Now, the issue here is that once they reach 25 kilometers total distance apart, they lose radio contact. So the question is, how long will it be until this happens? So the question is, how long until they reach 25 kilometers total distance apart? All right, let's categorize our information here. Cyclist 1 is going in kilometers per hour. He's going 20 kilometers per hour. Cyclist 2 is going 25 kilometers per hour. And total distance in kilometers is 25 kilometers. This brings us to question, how do we express how long they are going for? Well, the question asks us how long will it be before they lose radio contact. Therefore, that's what our x should mean. X is time until lost radio contact. So if you think about it, they start at the same time and they're going to be 25 kilometers apart at the same time. Therefore, they're both going for X hours each. So 20 times X would give us the distance of the first guy, and 25X would be the distance of the second guy. So if we add their distances, we want to force the equation to say that their total distance will be 25 because that's the time that we're looking for. So let's solve this. We get 45x is equal to 25. Divide by 45 on both sides, you get x is equal to 25 over 45. Remember, x means the time until radio contact is lost, so it's in hours. However, 25 over 45 is a decimal, and that doesn't describe the time very well. It actually turns out to be 0.5 repeated, which would be around 0.6 of an hour. That's approximate, so let's see if we can make it more exact. Let's simplify this fraction by dividing both sides by 5. We get 5 over 9, 5/9 of an hour. So, if we want to turn that into minutes, remember if you want to turn hours into minutes, you just multiply by 60. So let's try that out. 5/9 of 60 gives us 33 1/3 minutes. So it's about 33 minutes and 33 seconds approximately. So you have a few options for the final answer here. You could say this. You could say 5/9 of an hour. You could say 0.5 repeated or 0.6 approximately of an hour. So you have a few options here, but please just show all your work and make it as clear as possible.